Good afternoon, everybody. It is our pleasure to present our presentation of our current research work in International Conference on Oncology and Cancer Research under the category of Lifetime Achievement Award. My name is Subrahmanyam Pitchika. I am from Department of Pharmaceuticals, Geetham School of Pharmacy, Visakhapatnam, India. Just let us go through the current working title of my research work, that is Paclitaxel and Lapatinib, dual drug-loaded chitosan-coated PLGA nanoparticles enhancing cytotoxicity by circumventing MDR1-mediated transdermal resistance in head-to-positive breast cancers. We have done both in vitro and in vivo studies. If you see the contents of my current discussion, that is the overview of statistics, introduction to the breast cancer and drugs polymers of my current research, objective, background of the study, materials and methods, results and discussion, and summary and conclusion. Acknowledgement just follows up the conclusion. If you see that introduction of the statistics of the breast cancer that where I have selected for my current research work, it is 1.67 million new cases has been diagnosed in 2012. Breast cancer considered as the second most common cancer type in the world. According to the recent statistics in 2020, breast cancer became the most commonly diagnosed cancer type in the world. There are more than 2.26 million new cases of breast cancer and almost 6,85,000 deaths from breast cancer worldwide. If you see the estimated number of new cases in 2020, all cancers of both sex and all ages, Asia is in top place, having constituting about around 49.3%, and rest of the follows. If you see the top cancer per country, estimated number of deaths in 2020, both sexes and of all ages, lung and breast cancer of constituting more in the individual colors represent different type of cancer that is predominantly present in that particular place. If you see the estimated number of cancer new cases in 2020 of world females, specifically of all ages, breast cancer stands first in position, which is constituting around 24.5%. If you see the estimated age standard incidence and mortality rates, incidence of breast cancer is more and mortality is coming down, and it is being recorded in 2020 statistics. And drastically, there are quite a number of research works done and treatments available for the different types of cancers in current scenario. If you see the occurrence and development of cancer in their lifetime, it is 1 in 4 in men and 1 in 5 for women. And the worldwide die from cancer, it is 1 in 8 in men and 1 in 11 in women. And if you see the leading cancer types in 2020, so for overall sexes, it is breast cancer stood around 2.2 million new cases has been reported. When you go specifically for male, it is lung cancer, and female, it is breast cancer, which constitute about 14.3 and 24.5%. If you see the breast cancer, go through the interaction for a couple of slides. The cancer of cells of breast is known as breast cancer. It is conditioned and characterized by uncontrolled growth of cells, which lead to formation of lump in breast. And cancer originating from lobules, it is lobular carcinoma, and resulting from ductile cells, it is ductile carcinoma. If it is specifically constrained and restricted to one particular origin or tissue, it is invasive carcinoma. And if it is moving out and spreading other tissues, it is invasive. And if it is limiting to one particular tissue, it is non-invasive form of carcinoma. And other breast cancer types which are commonly included are inflammatory breast cancer, phyllodes, breast cancer, phyllodes, dysplasia disease of nipple. If you see the risk factors for the breast cancer occurrence, it is mostly age and gender are going to be critical factors. Apart from these, genetic factors which are constituting around 5%, and other factors like menopausal age, obesity are found to be associated with the breast cancer. And other factors that are influencing for the occurrence of breast cancer are smoking, exposure, radiation, etc. Breast cancer classification, if you see, it is 4 different types of classification that has been described as of now, based on stage, grade, histopathology, and receptor status. But it is best classified based on receptor status as of now to study in detail. But studies shown that combination approach is more beneficial. Coming to the cell lines that we study for the cellular mechanisms of the different types of cancer. Cellular cell lines are the cell cultures which are grown in vitro and picked up upon the biopsy of particular tumor tissue and grown in cell lines. Cell cultures and cell lines have been developed from them. And the different cell lines have been used to study the cellular mechanisms, and cancer cells are obtained from different patient tumors and cultivated into cell lines. Cell lines are the first cell line that has been reported in 1958, that is B20, and the breast cancer cell lines have been obtained from breast cancer patient specifically. And this particular database has been included of all different types of cell lines has been included in CCLE, that is Cancer Cell Line Encyclopedia. This has been maintained by Broad Institute and Novartis. If you see the pie chart of this particular different types of cell lines, it is breast and cancer and lung small cell cancer stands in the top one, and as per the statistics. And if you see this number of cell lines, that is 56 cell lines are available for breast and 51 for lung cancer, and the other all are being respective cancer has been reported with respect to cell line number. And for the current research, we have selected two drugs, that is Paclitaxel, which is of category antimicrobial microtubule agent, and the class taxane chemotherapy. Approval status of this by FDA is used alone or in combination with other anti-cancer drugs to treat breast cancer and lung cancer and ovarian cancer. If you see the mechanism of action of paclitaxel, it targets microtubules at a high concentration. PTX causes mitotic arrest at G2 by M phase, whereas at lower concentration, apoptosis is induced at GO and G1 by S phase of via kinase activation. The common side effects of this drug is bleeding, destroying, burning, illness, etc. You see the second drug that you have used for the combination study, Lapatinib, which is of anti-tumor activity category and class kinase inhibitors. This has also been approved by FDA to be used alone or in combination with other anti-cancer drugs to treat breast cancer and lung cancer. You see the drug mechanism of action of second drug, that is Lapatinib. It inhibits thyroid kinase activity associated with two oncogenes, that is EGFR and HER2. Overexpression of this HER2 can be responsible for certain types of high-risk breast cancers in women. Lapatinib inhibits receptor signal processing by binding to the ATP binding pocket of EGFR HER2 protein kinase domain, preventing self-phosphorylation and sequent activation of the signaling mechanism. If you see the common side effects of this drug, nausea, vomiting, upset of stomach, mouth sores, etc., are the common side effects of this drug. Whereas this Lapatinib is basically anti-cancer drug developed by GSK, that is GlaxoSmithKline, as a treatment for solid tumors such as breast and lung cancer in 2007, and along with in combination with capecitabine to treat advanced metastatic cancer, HER2 receptor positive breast cancer in patients who have received already the cancer treatments like taxane, trastuzumab, and anthracycline, where it does not work well. This is a pictorial representation of the two drugs, how it is going to act in the body. And the polymers that we have used in the current research work, that is PLGA, is a copolymer of PLA and PLGA, which is investigated because of the biocompatibility and biodegradability, which is why it has been extensively used. And solubility of this polymer is in DCM, and that is dichloromethane and acetone. And the other polymer that we have used for coating is chitosan, that is originated from a crustacean cell, insects, exoskeleton, and some fungi, mainly chitin. If you see the background for the study, we have done that has been done from the last 2 decades. There has been great deal of progress have been done in the developing HER2 positive breast cancer treatments. US FDA has already been recommending to use trastuzumab, pertuzumab, and lapatinib as commonly used anti-HER2 drugs, whereas trastuzumab, a homogeneous recombinant monoclonal antibody that binds to HER2, has selectively anti-tumor effect that lead to downregulation of PI3K signaling pathway and downstream mediators of cell cycle progression. If you see the lapatinib is basically a dual tyrosine kinase inhibitor that works binding TK domains of HER2 and EGFR, serves as an ATP competitor by inhibiting phosphorylation and signal transmission of the PI3K pathway, reducing cell growth and inhibition, inducing apoptosis upon interaction with receptors. Although paclitaxel is not intended to be monotherapy for HER2 overexpressed breast cancers, it can be used in combination with other anti-HER2 drugs, depending on the severity of the cancer and the stage of metastasis and early treatment. It is highly successful in earlier and metastatic breast cancers. If you see the selection of nanoparticles agents for delivery, why we have selected it particularly nanoparticles, because this has been optimally simultaneously can release a dual drug existing with respect to individual existing formulations. Nanoparticles encapsulating one or more particles can deliver the agent simultaneously and in a more optimal, proportional, and extremely challenging way. Further process of drug efflux mediated by ABC cassette transporters is inherently minimized when nanoparticles are used as delivering agents, as the nanoparticles enter the cells primarily by endocytosis. As a result, the majority of drugs given by ion particles are less susceptible to drug efflux pumps due to their replacement within the cell, which is typically outside of the reach of the membrane efflux pumps. This can be already been studied in quite a number of studies where you can see this particular study in ovarian cancer as well, where different nanoparticles and other studies has been done. However, the combination of paclitaxel and lapatinib has not been investigated in MDR1 mediated multi-drug resistant head-to cancer model till date. These are the basically different types of nanosized drug delivery vehicles, that is polymeric nanoparticles, liposomes, nanosuspension crystals, solid lipid nanoparticles, and nanotubes and nanowires. Polymers are basically here we have just classified to have a reference for your here are natural, synthetic, biodegradable, and non-biodegradable have been classified here for your just overlook of that. The main objective of my current research work is to develop a chitosan-coated dual drug, PLGA nanoparticles, to improve anti-cancer drugs, anti-cancer effects by considering the wide range of nanoscale advantages of PLGA, that is a polymer that we have used, and increasing permeability capabilities of chitosan, which is the coating over PLGA particles, thereby overcoming MDR resistance with synergistic efficacy in HER2 overexpressed breast cancer models. You see the materials and methods further in the presentation. We have basically cell culture and establishment trastuzumab resistance cells has been done by stepwise resistance induction with increasing concentration of trastuzumab from 10 microgram per ml till 15 microgram per ml, which you can just have a look in the results path where we have established the rate as well. Recombinant monoclonal humanized monoclonal HEL2 antibody of transfer concentration has been increasing, and we have developed a resistant cells. Further, in vitro cytotoxicity of free drugs, we have evaluated the optimal intracellular drug ratio of PTX and LP, that is paclitaxel and lapatinib, using MTT reagent, where we have placed in different well plates. After 24 hours, the cells were exposed to serial dilutions of single drugs or drug mixtures at different concentrations for 48 hours. Later, the MTT reagent was added, and further cells were cultured for additional 4 hours. When the cells culture media was removed from each well, the treatment was done with the added of addition of 150 microliter of DMSO, methyl sulfoxide, then examined at to 550 nanometer using ELISA plate reader. The percentage of viable cells is measured compared to the survival of the control group, computed using absorbance intensities for the triplicate trials that we have done. And the third that has been done using graph prism software. The IC50 values of free paclitaxel and the pattern solution and combinations were established and estimated, and following a set of dose response data where we have determined the reversal index of Lapatinib is calculated, and also the combination index has been determined to know the reversibility of the drug combination. And if you go the preparation of the dual drug loaded nanoparticles, we have used double emulsion solvent evaporation approach, where we have first synthesized these dual drug loaded PLGA nanoparticles for different compositions. We have tabulated in the next upcoming slides. Following preparation, we have centrifuged the nanoparticles were distributed in 25 ml of distilled water. The nano dispersion was stayed for 3 hours with an equivalent volume of chitosan solution to facilitate the development of chitosan-coated nanoparticles. All the nanoparticles the formulation developed were stabilized for 3 days at minus 60 degrees centigrade in a freeze dryer. The formulation of this study were prepared in triplicates. This is a basic pictorial representation of how we have prepared polymer drug DCM, that is dichloromethane in organic phase, transferring that to an aqueous phase containing water and PVA. Then emulsification is followed. Then solvent evaporation. Then the centrifugation is done, and nanoparticles have been nanoparticles has been centrifuged, and that were collected separately, and the nanoparticle in solid state has been determined. These are basically the composition and the different formulation trials we have done, and the molar ratio of the Pitchika-Paclitaxel and Lapatinib remains same in the ratio of 3:1 molar ratio. And we have studied PLGA polymer at 3 different concentration, 30, 60, and 120, and emulsifier at 2 different levels, that is 0.5 and 1%. Concentration of chitosan-coating at 0 and 1 level, and that is 2 levels. We see the calibration and optimization of paclitaxel and the patent-loaded drug nanoparticles. We have studied, as we discussed, we have studied in 3 different factors have been studied, and carrier concentration PLG at 3 different levels, emulsifier at 2 levels, and at 2 levels of chitosan coating. HPLC was further used to determine the encapsulation efficiency and drug loading. The paclitaxel were quantified with a mobile phase of 70 to 30 acetonitrile water volume level at a detection wavelength of 2 to 7 nanometer. And Lapatinib were measured with a mobile phase of 60 to 40 monocitrate in water at 0.17 ml per minute at a detection wavelength of 272 nanometer. Later, we have calculated and computed drug loading and therapeutic efficiency. Following this, we have determined percentage yield, particle distribution, and particle size data potential of the optimized formulations, where we have used this data size as a nano 90 ZS to determine the particle size, PDI, and other data potential values. Using the determined at 25 degrees in the dynamic light scattering after temperature equilibrium. These experiments were repeated in triplicate, and the findings were expressed as a mean and standard deviation. Morphology of the current formulations has been done using transmission electron microscopy, that is STEM. Due to the choose only of selected chitosan-coated nanoparticle formulation we have done, and that has been given in the results part section. And the technique used for this of phosphotungstic acid negative dye was performed, and all the formulation was photographed by placing the grid into the specific chamber at optimum cell resolution. Stability of these selected formulations of uncoated 5 and 7 and coated 6 and 8 were evaluated in a phosphate buffer cell line, that is PBS, for 12 weeks based on particle size, PDA, zeta potential, and encapsulation efficiency. Further, they were stored at 4 degrees centigrade. In vitro release was done for specific uncoated and coated formulations, that is coated 6 and 8 formulations and uncoated 5 and 7. Lyophilase formulations were measured using dialysis approach, and further RPM that is maintained for this study was 70 RPM and 37 plus or minus 1 degree centigrade of temperature was maintained, and the sampling was done till 72 hours. And for every time point, 0.5 ml of media was withdrawn and replaced with the equivalent volume of fresh media to maintain synchronous conditions. And HPLC was used to determine the concentrations at the different time points, and also were analyzed by Weibull statistical distribution function, where its overall superiority for fitting the drug released by nanoparticle nano delivery systems is good. In vitro quantitative cellular uptake of nanoparticles to begin, we have quantitatively measured the intracellular drug content of both BT474 and BT474 trastuzumab resistant cells in the 6-well plate where we have seeded. After overnight incubation for the specific formulation of coated 7 and 8, which is with and without coating, and were added to the final concentration of paclitaxel, which is in ratio of 3:1 by 1 molar ratio of 15 microgram paclitaxel and 5 microgram Lapatinib, which is then incubated at 37 degrees for 4 hours. Following incubation, media was withdrawn and the cells were washed twice with PBS to remove unbound NPS. Cells were then centrifuged at 1000 RPM to recover, which were subsequently reserved in PBS and Triton 100 solution. After lyation using ultrasonic laser for 5 minutes in water bath, the concentration PV and the paclitaxel and Lapatinib were determined using HPLC, and cytotolerability of 7 and 8 formulations at different time intervals of post incubation with both resistant cells MTT assay were performed. Observation of cell morphology is being done for specific CS coded formulations, that is 7 and 8. For 24 hours, it has been treated with loaded cells in a 6-well plane, and using an Axio CCD cam, the cell surface morphology of PT was 7474 and resistant cells were studied and images were taken. In vitro Sanskriti, again, we have done placing the resistance and non-resistant BT474 cells were placed in a density of 3500 and 5000 cells per well in a 96 well culture plate. After overnight incubation, the media was replaced and the selected formulations of 7 and 8 were added to the final concentration in the ratio of 90 90 nanomolar and 30 nanomolar PTX-LPB in the ratio of 3:1 by molar ratio. After 24 incubation, MTT reagent was added, and further study was done after incubation of 4 hours. And formazine crystals were dissolved in DMSO and using a microtiter spectrophotometer were used for quantitative analysis. The percentage viable cells are indicated based on survival of control group computed using observing intensity. Each experiment were done in triplicate as well. If you see the PGPP P glycoprotein 1 activity was determined by measuring the intracellular deposition of calcium fluorescent anionic dye. As per the manufacturing procedure using the multi-drug resistant assay calcium acetoxin methyl ester, that is calcium AM, is a lipophilic non-fluorescent dye that is first into cells and is converted into the hydrophilic intensively green fluorescent calcium by the cytosolic esterase. The activity of PGP was quantified as a percentage of fluorescence detected in treated wells compared to untreated control wells. When coming to the Western blotting technique, we have investigated the effect of various treatments, including free drugs, binary mixtures, and coated formations of aid on trastuzumab resistance mediated by MDR1 and other cellular growth events in resistant cells and BT TR trastuzumab resistant cells. MDR1 kinase receptor regulated EGFR HER2 and their phosphate partners were examined. For this, we have seeded in 9-6 pill and along treated with the play. 24 hours of culture, cell was treated with the free paclitaxel and LPG, Lapatinib in the ratio of 45-15 nanomolar, which is in the ratio of 3:1 by molar, or binary mixture combination of Lapatinib and paclitaxel, or with the dual drug chitosan-coated nanoparticles, that is formulation 8 at the same concentration for 2 hours. Later, we have washed with ice cold lysis and treated with the 50 millimolar tris, 10 millimolar ADTA antitonics 100 and supplemented with the protease inhibitor cocktail set 3, which is we have procured. And later, we have sonicated acid with 13,000 gram, approximately 20 microgram protein extract were separated from the HTC page and probed with the following antibodies. Then we have determined to ensure the controls were loaded equally in lysis, samples were probed with an antitubulin antibody. And in the study we have done obtaining the approval of the Institution Animal Ethics Committee IAEC and CPCSEA. And accordingly, we have treated them Himalayan hours in the groups of 5 under 12 hours light and dark cycle. Tumors were developed in the biopsy mice for 4 weeks old by subcutaneously injecting BT474 transdermal resistant cells in the upper back area. Tumor development was examined twice a week using using a calculus by measuring tumor's length and width. And when it attained 1,000 free of size, we have just started treating, separating that particular thing, and then with intravenous injection saline control also, and we're arbitrarily separated at the tumor width. Then we have started treated with administered doses of 1.5 and 0.5 mg per kg, respectively, with the molar ratio of 3:1. And the tumors and body weight of mice were evaluated regularly. After 11 sessions of therapy, all mice were examined. In the efficacy study, were done provided as means of SD standard deviation. The results were analyzed using one-way analysis of ANOVA, that is variance. And to this day, the p-values of less than 0.05 were considered significant. If we see the results and the discussion part for the methods and materials that we have done so far. Establishment of transfusion, you can see on day 5 to 30, where we have a cell growth of optimal density as a fold of control. And for the same thing from day 31 to day 220, which is having an increase with a molar ratio of 15. That is, initially we have done with 10, and later we have continued till 15 microgram per liter. And the same, if you see here, confirmation of the transfer index in BT477 cells, the different transfer concentrations have done, and both have been graphed over here. And the optimization of combined formulation we have done so far for the 8 different formulations, and IC50 values, reversible index and CA values have been computed, and reversible index of combination of 50 nanomolar concentration will be reached 13.43, representing the highest potency to reverse the TPZ, and that is trastuzumab and paclitaxel resistance in BT474 trastuzumab resistant cells. The maximum percentage of this cell growth suppression of this particular paclitaxel 50 million and Lapatinib was 98.14, plus minus 0.59% BT resistant cells with a milli ratio of 1 molar of paclitaxel Lapatinib combination. This is a combination of 8 formulations where we have determined individual entrapment efficiency of paclitaxel, Lapatinib, and average of that, drug loading of individual drugs, and average of that. So if you see the 8 formulation, we have an 84.4% and 72.2% for Lapatinib. Overall, it constituting 80.8 of entrapment efficiency and the drug loading of 1.5% overall for individual drugs. And then it means the average of DL of nanoparticles. If you see the optimization of formulation for the formulation 7 and 8, drug loadings and entrapment efficiency have been individually plotted, and the CS-coated nanoparticle demonstrated that the percentage drug loading compared with uncoated formulation, probably because of the strong holding tendency of the CS or PLGA carrier dual loaded, that could stabilize the nanoparticle by properly protecting the structural architecture. That is how the 7 and 8 remains constantly checking with that. 7 is an uncoated, and the 1-8 formulation 7 and 8 showing the coated and uncoated differences. You see the yield percentage yield particle size PDA and zeta potential of the combinations of 6 and formulation. We have 8 and 6 formulation to compare reciprocally with the different percentage of coating of chitosan 0 and 1, where we see PDA values of 0.185 and 0.229 respectively, indicating moderately narrow particle size dispersion. The use of PLGA as carrier for normal delivery for anti-cancer tumor targeting has been extensively described in literature with multiple success stories. So zeta potential value for uncoated formulations 5 and 7 respectively, and their confirmed blank NPS were also exhibited negative zeta potential values because of the uncapped carboxylic groups in PLGA polymer, and the negative surface charge is expected on both NPS. Similarly, you can see a positive zeta potential is caused by amine groups in the CS structure, which is the coated one, indicating the CS is successfully coated onto the PLGA and PS surfaces. So if you see the formation of 8, it is 263 particle size has been observed, and zeta potential is 13.5, which is the positive side. If you go to the morphology, this is the pictorial images that we have taken using the camera, that is XUO-CGD camera. The one A and D indicates the nanoparticle coated formulation, and the next two, that is B and E, are the blank one. The B is the blank one, and the E is the blank of PLG nanoparticle 6 formulation, and the last two are the just the uncoated one. Next, if you see the stability of these formulations, the storage at 4 degree of Lapatinib dual coated formulations, particle size and PDA, zeta potential, and encapsulation efficiency every 2 weeks with the optimal intermediate formulations has been done. And both 6 and 8 showed a stable zeta potential varied between 21.5 and 24.3 and 13.5 to 15.8 milliwatt, respectively, over 3 months. CS coated formulations of 6 and 8 had a stable PDA reported were 0.186 and 0.221 respectively, and it remained steady at 0.192 and 0.231 respectively after 3 months. If you see here the representation of the stability data, the particle size at week 0 to week 12 of 5, 6, 7, 8 formulations. The similarly polydispersity index and zeta potential and percent efficiency has been calculated and tabulated for the last 4 formulations, that is uncoated and coated percentages. Same as well here, and entrapment efficiency of paclitaxel and Lapatinib in dual drug loaded value PLG and nanoparticles for after 3 months. We have just plotted here. And in vitro release has been done at a pH of 5, 7.4, and 6.5 for different formulation. Cumulative paclitaxel release has been done, and cumulative Lapatinib combinations has also been done. And the different combinations shows that the highest cumulative average of dual drugs compared to nanoparticle formulation 6. NPS 8 is having more advantage at 72 hours, and it is performing very good with an average of 96.2. So based on the maximum value of R that is greater than 0.9 obtained in the case, the release kinetics matches the viable formula. The in vitro cellular uptake of NPS, we have just taken the quantitative cellular uptake of PT, paclitaxel and Lapatinib loaded PLG and nanoparticles formulation in both BT 474 and resistant transfer resistances. This were expressed as a mean one. So 8 formulation you can see for paclitaxel and Lapatinib individually. And this is the cellular morphological changes that you can see. There you can find A and B to be the control cell lines for BT474 and resistant cells. C and D are a treatment of NP8 with equivalent quantity of 9 and 3 microgram per ml of paclitaxel and lapatinib respectively in resistance and non-resistant, that is C is BT474 and the BT474 transmission cells is the D1. And you can see the E and F where treatment of blank NPS8 with equivalent quantity of PT474 and 474 resistant cells has been done. If you see the in vitro cytotoxicity studies, the control everything finds good with the NP8 formulation, that is CS-coated with respect to percent viability in for PT47 cells as well as BT47 transhuman cells. MTT results of the efficacy of different treatments on in BT474A and BT474 with a standard deviation of n is equal to 3 treatments has been done, that is in triplicate. Inhibition of PGP activity in PT474 transfer resistant breast cancer cells has been done using calcium AM test, where formulation 8 NPS nanoparticle formulation 8 is been showing overcome transfer resistant BT474 transfer cells, and result revealed that the transfer cells BT474 transfer resistant cells show the lowest intensity compared to BT474 cells due to their inability to uptake calcium, and that would be resisted by PGP activity in the cytoplasm. That is how it is being pictorial represented over here graphically. And NP8 has the same impact that we have studied earlier. And this has been performing well with respect to inherent resistance. We see the treatment of PT474 transfer cells with the paclitaxel combination dual drug load and nanoparticle down regulation and DR1 restricted F2 signaling. Results show that free Lapatinib and binary mixtures fail to inhibit MDR1 expression in transfer resistant cells, despite strong reducing F2 and GFR expressions has been shown by NP8 formulation. So that is how our formulation been a successful one in attaining our target. The same has been done to prove in vivo anti-tumor effect as well, and the combination drug of formulation 8 has been given in agonist transfer-resistant blood cells in xenograft mice, and the comparison to cell line control, mixture, and single drugs as well as nanoparticle formulation has been given simultaneously to study the effect of anti-tumor effect. So you can see the NPS 8 formulation is having the least tumor volume with respect to in MN3, and thereby showing best preventing tumor progression compared to cell control. And that is being estimated after 11 treatments over 37 days. NPA8 demonstrated considerable anti-tumor effectiveness in preventing tumor progression compared to cell control. Further statistical significant difference in the rate of tumor mass inhibition. Table 7 was identified between formulation 8 and other study pro groups P, which is less than 0.05. The inhibition efficacy of formulation 8 against BT474 transcription resistant xenograft was 81.52%, which is very good, and indicated that the combination when administered via chitosan-coated PLGA inhibitors may promote intra-tumor accumulation and ultimately result in cytotoxicity. This is most likely a result of downregulation of PGP, which was observed in transcription resistant BT474 transcription resistant cells in vitro as well. So that is how tumor mass for this combination NPS8 is 0.18% as 0.11 gram was observed, and inhibition efficiency was 81.52 as we discussed. Further, if you see the conclusion of our current research study, this is the first study to validate or evaluate biocompatible nanocarriers coated with chitosan for dual drug loaded paclitaxel and lapatinib as a novel tool capable of down-regulating PGP1 expression and rescuing trans-tumor and paclitaxel efficacy against resistant HER2 positive breast cancer cells. Paclitaxel and lapatinib combination was shown to have earlier molar ratio of 3:1 in an in vitro cytotoxicity assay. Compared to chitosan-uncoated formulations, the dual drug-loaded coated formulations of chitosan with synergistic effect was seen in vitro release of paclitaxel lapatinib demonstrated rapid release. The other findings that we have significantly found is all PGP1 inhibitors discovered in the recent years have consistently failed due to their low sensitivity, high toxicity, and PGP1 inhibition in non-transformed tissues. But in vivo examination revealed that encapsulation of both the dual drugs, paclitaxel and lapatinib into PLGA nanoparticles at a synergistic ratio resulted in significant anti-tumor activity in multi-drug resistant BT474 tumor resistant, trans-tubab resistant tumor xenograft mice. Our findings are therapeutically significant because adjuvant chemotherapy is one of the most advanced therapeutic choices for HER2-positive breast tumors. In this regard, finally, I would like to thank Dr. Ramarao, who is the Dean of Geetham School of Pharmacy, Visakhapatnam, India, and Dr. Suvendra Kumar Sahu, Assistant Professor in Geetham School of Pharmacy, Geetham University, India, for their valuable support and help throughout my research work. And I would like to also to thank Research Lab of Geetham School of Pharmacy for providing the necessary facilities to carry out my research work activities, and IRC team of Geetham as well. Thank you very much giving this opportunity for me to present my presentation in oncology research, Pencis Oncology Research Site. And this is my recent journal based on which the research work has been published in the Journal of Drug Delivery Science and Technology, and you can find it as well. Thank you very much for giving me this opportunity to present my presentation in International Research Awards. Thank you very much.